Hi, so in this video we will talk about permutation. Permutation is a number of ways of how things can be arranged. Okay, permutation is a number of ways of how things can be arranged. So that is the permutation. So it has to do with counting. So you have to count how many ways that this thing can be arranged, and then after you count the result of that, that is now what we call the permutation. So let me give you a simple example. Let's say we have a red, green, and blue balloons. How many ways that these green, red, and blue balloons can be arranged? So what we will do is to make different combination of these balloons, and we will count the number of ways that these balloons were arranged. So let's start by writing here the red, green, and blue. So this is the first permutation, first order. Okay, this is the first order, or order number one. Another way of arranging this is we have the red, blue, and green. And then we can arrange this with another order. Let's start with green, then red, and then blue, and then green, blue, and red. And then we can also start with blue, red, and green. And then the last one is blue, green, and then red. So how many orders do we have here? So we have red, green, blue. That is the first order. The second order is just we flip these two, red and then blue and green. Then after that, we use the green as the first item, and then the red is the second item, and then the blue as the third item. And then again, we still use the green, and then we flip the R and B. So we have now the G, B, and R. And then for the last two orders, to arrangement, possible arrangement is the blue. So we have blue, red, and green, and then we will just flip these two. It will become blue, green, and red. So the total permutation of this is, we will just count 1, 2, 3, 4, 5, 6. So 6 permutation, 6 ways, or 6 permutation. So that is the basic idea of what a permutation is. So what you have to do is just to count every combination, and the total orders or arrangement that you will get is called the permutation. Okay, so let's have another example. So this time, let's take this example. Let's say there is a race of bicycle. Let's say problem number one. We have a bike race, and then you're asked to how many ways so the problem goes like this. You have a bike race, and then you are asked of how many ways can first and second place finish. Considering that you have 4 racers. So from 4 racers, how many ways can first and second place finish? Okay, so let's say we have these racers, Steve, So these are the racers. Given this 4, how many ways can first and second place finish? For us to identify the permutation of this case, what we will do is to make a tree diagram, assuming that each racer from this list to be the first placer, and then assuming the rest to be the second placer. So let's write down here. We have Steve, then we have Steve. If Steve is the winner, then probably the rest can be the second placer. So for the second placer, it can be John, Smith, and Wilson. That is, if Steve is the first placer. So there are probabilities that John, Smith, or Wilson can be the second placer. What if Steve is not the first placer? Let's say John is the first placer. If John is the first placer, then probably Steve and Smith and Wilson can be the second placer, any of them. So if Steve is the first placer, so probably it is John who will take the second place, or Smith, or Wilson. But if John is the first placer, so probably it can be Steve, Smith, or Wilson will take the second place. Same goes with the rest. If Smith is the second placer, so let me erase this first. If Smith is the second placer, first placer, then probably it could be Steve, John, or Wilson can be the second placer. If Wilson is the first placer, then probably it can be Steve or John or Smith can be the second placer. So remember, we are looking after the first and second place. So if Steve is the first placer, probably John can take the second place, or Smith can take the second place, or it is Wilson who can take the second place. But if it is John who will be the first placer, so probably it can be Steve who will take the second place, or Smith can take the second place, or Wilson. But if Smith is the first placer, then probably the second placer can be Steve, John, or Wilson. And if Wilson is the first placer, probably the possible winner for the second place are Steve, John, and Smith. So these are not now the total number of permutations. So how many permutations do we have? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 ways. So we have 12 ways or 12 permutation. So that is how you do the permutation. Now, this question comes in. Let's say you have thousands of racers for this problem. You have thousands of racers for this problem. And then you were given of how many ways can first and second place finish. So what you will do is to plot this just the way we did on this example. It will take you a lot of time before you can get the number of ways or the total permutation for the given problem. You will not do this technique of writing a tree diagram for each event and then counting the number of ways. so that you'll be able to get the number of permutation. It is so much time consuming if you will do this or solve a problem similar to what we did on this problem. So that is why I'm going to introduce to you the fundamental counting principle. So what is the fundamental counting principle? It is stated that the number of events, which in this case, how many events do we have? And this example, we have two events, 1, 2. So we have two events. So since we have two events here, we will look on the number of ways that occurred on these events. So in the first event, how many ways do we have here? So we have Steve, John, Smith, and Wilson. So how many ways do we have for the first event? Our first place and second place are the events. The events are the first and then the second. These are the events. So how many ways do we have for the first event? So let's count. Steve, John, Smith, and Wilson. So 1, 2, 3, 4. So we have 4 here, no? We have 4. 4. For the second event, how many ways do we have? So 1, John, Smith, and Wilson. That is the number of ways that we can get from the second event. We will not count the total persons that we have for our second event, because the people here are the same people for the second occurrence of the event. So John is here, but John was placed on the first place, but Steve and Wilson Smith are still here. So we will just count the first occurrence. So how many ways that first event occurred? 1, 2, 3. So we have 3. So we have 3. So what you will do is to multiply the number of ways that occurred on the first event, which is 4, times the number of ways that has occurred in the second place, that is 3. So 4 times 3 gives you 12. That is why we get 12. So if you're given a problem similar to this, you will not plot the whole combination, the whole tree diagram just to get the total permutation. You can make use of the fundamental counting principle. You will just count the number of ways for the event and then multiplies those number of ways per event. And then you will get the total number of permutation. If you have first, second, third, fourth, what you need to do is just to get the number of ways for those events and then multiply those numbers. Then you will arrive in getting the total number of permutation. Okay, so that's all for this example. So this time, let's go to the definition or the formal definition of permutation. So from the formal definition of permutation, it only explains that a permutation of n elements is an ordering of the n elements such that one element is the first, one is second, and one is third, etc. To summarize this definition, what it wants to say is that the order of elements so the order of elements matter. So the n elements on the first together with the elements on the second and the elements on the third, and those elements is what is called permutation. Okay, so the order of elements matter. For each order that you have is considered part of the permutation. And then if you will count the total order that we get after accomplishing all the different ways of ordering elements, that is now called the permutation. Okay, so since we now know what is the formal definition of permutation, so it means that the order matters. Let's have another example of permutation problem. Let's say we are given this problem. So list all permutation of letters in the word bat. So we have three letters here, so meaning we can have this event 1, event 2, and then event 3. Okay. So for the first event, how many letters can be chosen from this letter? So we have three letters. After choosing the three letters, what will remain is we only have two letters left. So meaning in the second event, we only have two letters left. Because if we have bat, then the next arrangement probably would be just between the A and T. So we can interchange this to be B, T, A. So we have only two letters to choose from. That is why we have two. After choosing T or A, then we only have one letter left. So meaning on the event 3, we only have one to choose from. Okay, so we have two here, three for the first event because we have BAT, and then after choosing the B, so we have only two letters left. After choosing the T, we have only A left. So that is now the event 3. So that is why after getting the number of ways of ordering for the event 1 and the number of ways of ordering from the event 2 and for event 3, what we can do here is just multiply these numbers 3 times 2 times 1. So we get 6. So the total permutation is 6. We can still do the technique that we used on the first example, but we will still arrive at the same result, 6 permutation. Okay, so let's try applying the approach that we used on the first example. We will plot all the combinations of the word bat. So the first order is bat, and then the second order is BTA, then followed by ABT and ATB. Then the last two orders would be TBA and TAB. So let's count the number of ways we get from the permutation with the letters BAT. So 1, 2, 3, 4, 5, 6. So 6 permutations, which is equal to the number of permutation we get from the first solution that we have. 3 times 2 times 1, 6. And that's all for this video, and then see you in the next lectures.